So my topic is CPU scheduling, primitive and non-primitive. CPU scheduling plays a crucial role in operating system by allowing processor to utilize the CPU effectively, and two primary approach to CPU scheduling are primitive scheduling and non-primitive scheduling. The question is, what is CPU scheduling? CPU scheduling refers to the switching between processes and being executed. It forms the basic of multi-programming system, which switching ensures that CPU utilization is maximized so that the computer is more productive. Types of schedulings are non-primitive scheduling. This is the type of scheduling algorithm in which processes run till it finishes or goes to the wait state. We can't interrupt it while it's running. Algorithm include the popular first come first serve, in which order of execution is strictly based on the arrival time. As the name implies, the first to arrive is the first to be served. Advantages are offer low scheduling overhead, tends to offer high throughput. It is conceptual, very simple method, and their disadvantage are it can lead to the starvation, especially for those real-time tasks. Bug can cause a machine to freeze up. It can make real-time and priority scheduling difficult. Poor response time for processes. Primitive scheduling. Here the scheduling allocate the CPU to a process for a set period. After the time period passes, the process is interrupted and moved to the ready state. Therefore, primitive scheduling is which when a process transition from running or waiting to ready state, it consider priority, in which switching process giving room for a running process to be interrupted. An example of primitive algorithm is round robin. It gives all processes equal priority period, round or circular order as name implies. Another example is short remaining time first, which gives priority to the process with the shortest time left to completion. Pattern. Once the allotted time since is over to there is a high priority process read for execution. The running process is interrupted and it switches to the ready state and join the ready queue. Advantage of this are it ensure no process can monopolize the CPU, improve average response time. The OS makes sure that the CPU usage is the same by running process, avoid deadlocks. Disadvantage: extra time is required for interrupting a running process, switching between contexts, and scheduling newly arriving processes. Process starvation can occur, that situation where a low priority process wait indefinitely or for a long time due to continuous arrival of high priority process. Difference between primitive and non-primitive scheduling. It allocates the CPU to process for a set period of time, and non-primitive scheduling allocates the CPU to process until finish or goes to wait state. A process can be interrupted while being executed. In a non-primitive scheduling, a running process cannot be stopped while running. In primitive scheduling, a process can transit from running to the ready state or from waiting to the ready state. And in non-primitive scheduling, a process can transition from running to the waiting state or terminate. So in primitive scheduling, it flexible. A critical processor accesses the CPU without delay, and in non-primitive scheduling, it insists on a running process completing before any other processor accesses the CPU. Primitive scheduling, a low priority process can suffer starvation if high priority process arrive simultaneously. And in non-primitive scheduling, execution of a process with a high burst time can result in starvation process while suffer starvation. In primitive scheduling, process scheduling has associated overheads, and in non-primitive scheduling, no overhead related to scheduling. In primitive scheduling, highly CPU utilization, and in non-primitive, low CPU utilization. Thank you.